Hello and welcome to day 3 of our midterm showcases, the last day. But we've got plenty of exciting projects packed in for today. We'll be focusing on Payment Hub EE and Mifos Gazelle and a bit of AI and even a little bit of Mifos X in there as well. So plenty to keep you all busy today. If you're joining and wondering why we do the midterm showcase and what an intern is, well, hopefully this little video will give you an idea what our interns are all about. This year at Mifos, we continue our mission of creating impact. Impact created by our interns. Impact created by our mentors. Impact created by our global community. Together, we will create impact. We will create financial inclusion.
Honestly, it's really hard to put into words. When I found out I was selected, I just couldn't believe it. I had to take a moment to calm down because I was genuinely so excited. I think what makes this so special is that it's one of those moments where you realize that all those years of studying, all those late nights working on projects have actually paid off.
An email arrived from Mifos and the subject was MSOC 26 invitation. I read it once, twice, thrice. I couldn't process it. A paid internship, same project, same code base, same mentors, same everything. It wasn't just relief, it was a validation. I went from feeling invisible to being chosen. And that feeling of being seen, trusted, and valued by the organization like Mifos. I'll carry it forever. Thank you, Mifos.
What's unique about Mifos to me is that the mission is real, something that genuinely matters, that changes how you feel about the work. The other thing is the community itself. From the very first small contribution, people took the time to explain why things were done a certain way, not just what to change. It never felt like I was a stranger poking at someone else's code. It felt like I was being invited in. For open source, which can be intimidating to break into, that warmth is genuinely rare. So for me, Mifos is that combination: work that means something and a community that actually wants you there. Thanks, Mifos.
Hello and welcome. So we've got 8 people up today to present, actually 9 I think it is to present today. So it's going to be an action-packed day as we go through them all. But as I say, there's a community of 25 interns we've got this summer. So if you missed any of the previous presentations, both of the first 2 sessions are already up on our YouTube channel, and this presentation will be up shortly after the call finishes as well. Today's focus will be on Gazelle and Payment Hub. We'll switch back and forward a little bit. As I said, Mifos X in there and AI. But first of all, I'm delighted to hand over to Ismael. Ismael, do you want to introduce yourself and what project you've been working on this year?
Hi everyone, I am Ismael Sallami and my project is integrating OpenSPP into Mifos Gazelle, mentored by Tom Daly. I am from Granada in Spain and now I am on my Erasmus in Ireland. I am studying a double degree in computer science and business administration at the University of Granada. I am in my 5th year. And why Mifos? Because since first day they welcome me into open source, they are so supportive and help me every day. And because I think that my mixed background fits very well. About long term, I want to keep learning as much as I can across both software and finance, and I want to build my own company. About personal goal, I want to travel around the world and experience different cultures. And a fun fact, I am from Granada, home of the Alhambra and free tapas with every drink and every beer. So next slide, maybe. Okay, what is Mifos Gazelle? Mifos Gazelle is a tool to deploy a full open source payment stack on Kubernetes with one single command. But there is a gap, there is no social registry site, so it makes it impossible to register beneficiaries and drive government to person payment. So the goal is integrating OpenSPP as a first class DPG using that command. About implementation challenge that I have faced, I have to say that OpenSPP has no Helm chart. Image is built only and it brings its own database. So what I want to make is register vulnerable population and deliver subsidies. Next slide, por favor. Okay. What is runs today? What you are seeing is what are runs today. One command brings the whole stack up of OpenSPP. Users hits and gigs ingress and it starts the web traffic to Odo and WebSockets. Odo talks to the database PostGIS as a stateful set and a separate job worker which handles background jobs. And about secret, TLS, and storage are all wired in. Everything is fully self-contained in its own namespace, and I wrote the Helm chart and the deploy logic because none of it existed. Next slide, David. So the next phase, OpenSPP holds the registry, and this feeds Payment Hub, which checks, blocks, and initiates funds, and this settle in Mifos X, the core account, and the idea is connect them, but they already speak. So we hope that the payment path won't need a custom adapter, but that's still to be validated. Maybe there are one part which need an adapter. This is the registry, the beneficiary, but this will be in the payment hub side. So register someone and payment them is the goal of this next phase. Next slide, David. Okay, where am I now? I have validated and deployed full stack in the virtual machine. Okay, so I can say that I have done all tickets that I received in the first moment, and how we can see this deployment takes around 2 minutes, and the full stack fits in 16 gigabytes. And Davey, if you can play the video, please. Now, how you can see all service, all DPGs are deployed at the same time. So I can say that the goal is got. Okay. So next slide. Thank you, baby. What other on Kubernetes taught me a lot of things, okay? But the most important is that 200 okay can lie, because although return 200 even with 0 OpenSPP modules installed, so I have to verify the module directly in the database. Besides, the command and the args in Kubernetes are so different because I used commands and that overrides the entry point, breaking some jobs. So I fixed it using args. And other problems that you have to face when you enter in this world, like deal with different threats, disk issues, problems with debugging, and more like that. Next slide, David. Thank you. So the next steps, I have done and validate on the virtual machine everything, okay? The deploy, the image, the Helm chart, ingress, and docs. Now I want to do a demo with one of the products that OpenSPP2 have. It is about agriculture. Then I want to adopt the official OpenSPP2 image once it's published. And I want to publish my work and update the tickets in Jira. And finally, I want to make a reusable guide to how to add a new DPG for the future contributors. Next slide, David. And I want to say that huge thanks to my mentors, Tom, David, Ed, and the entire Mifos community for their guidance. And I have to say that I am so comfortable, and I am very happy to be here. So here is my contact details, and any question are more than welcome. Feel free to reach me. And with that.
Thank you, Ismael. That's great, and a great way to kick us off with some of the new features that we're hoping to get in Mifos Gazelle. It's an important part of the journey, that one, so that we can actually really show true end-to-end, right way from the beneficiary programs and social registration starting all the way through to delivering payments. So a great and exciting project, and good to see the work you've done on it so far. As you said, Ismael, as we go through this, we'll have contact details for all our presenters in there, and they are all more than welcome to get any feedback, any suggestions from the community as they continue over the next few weeks with these projects. So please do reach out to them within the community. We're staying on the topic of Mifos Gazelle. We will be moving on to Mohammad. Mohammad, tell us what you've been doing on Mifos Gazelle.
Yeah, so hello everyone. Am I properly audible?
Yeah, we can hear.
Yeah, so myself, Mohammad Gous. I am a third-year student at Kengne Sultanpur. I am currently in this summer. I will be working on OpenG2P integration into the Mifos Gazelle. So yeah, so why Mifos? Mifos was my first open source organization. Learned a lot from the people from here. They are really kind and helpful. About the career objective, I aim to deepen my understanding about financial technology and create impactful solutions. For my personal goal, I want to experience everything which I can't now because of my current situation. And yeah, fun fact, my cat acts as my coding breaker, as a break reminder. He's sitting right beside me and sits right in front of me if I ignore him for too long. So yeah, next slide, please. So about let's first discuss OpenG2P. What is OpenG2P? So OpenG2P is a open source platform that enables organizations and governments to deliver social benefits to the people of a nation or a community. It is a recognized digital public good housed at IIIT Bangalore, and it facilitates secure and inclusive, efficient registry program management capabilities and digital cash transfer. Uh, so currently, it comprises of four main modules: a social registry, which is a database, a really smart database, which can consist all of the nation's records, and then there is program and beneficiary management system, which acts as a management system for beneficiaries and the programs of a nation's benefits. And then there is a account mapper, social payments account registry, and then there is a G2P bridge, which acts as a bridge between the program and beneficiary management system to the upstream payment system. So next slide, please. So yeah, integration into Mifos Gazelle. So what Mifos Gazelle is, as Ismail has already explained you what Mifos Gazelle is. So yeah, it currently deploys three main components: the Moja Loop VNext, Payment Hub EE, and Mifos X. So yeah, together these three forms a strong core banking and payment systems. And the next on the roadmap is OpenG2P, which will act as a registry and program management system for giving downstream for giving a downstream information. And then it currently before Gazelle deploys these three, and the next is OpenG2P. So the aim of this project is a easy demo deployment of OpenG2P using a simple run.sh command. Next slide, please. So the current integration mechanism. So OpenG2P will be deployed via OpenG2P.sh core deployment script, which will handle all the Helm deployments, retries, pod management, etc. for the OpenG2P systems. Uh, the deployment is based on Helm charts, where the values are pulled at the deploy time, where the charts are pulled at deploy time and is overridden by values for a custom deployment experience. A config.ini is also present for each to toggle each of the modules in the deployment. For the routing and access layer, we have the existing Nginx of Mifos Gazelle, which will handle the routing and request of the user. Also, we will be using the existing per module subdomains of Mifos Gazelle. For the end-to-end demo, we will be deploying social registry and program management system along with the core three Gazelle apps, that is Payment Hub, Mifos X, and VNext. So the beneficiaries are registered in the social registry, which will be fetched via the program and beneficiary management system over G2P Connect APIs. And then the disbursement will be routed through a payment manager in Payment Hub in program and beneficiary management system, uh, which will be routed to the Payment Hub EE. The Payment Hub EE orchestrates the payments from Mifos X existing tenants and clients to the to settle payments in the Mifos FinRack ledger. This is a deployment architecture. where each of the modules are separated by their namespace, so we don't have any collisions. Where the access will be through Nginx ingress gateway. Next slide. So project roadmap, till now, I have the more core of this project was investigation. Cause if the if the upstream project is already not properly implemented, I can't properly integrate into Mifos Gazelle. So involves a lot of investigative tasks. So right now I have deployed OpenG2P in my current systems and verified everything is working. Then I have also initiated G2P demo payment using all the three Mifos Gazelle stack. And after that, I have also completed the OpenG2P.sh, the core deployer script, which can automate the deployment and can run Mifos Gazelle apps along with OpenG2P in about 30 minutes. And then there is the tasks which are in progress, that is the post deployment configurations of Voodoo extensions and other informations. And then there will be the end-to-end payment verification, which will be done after I have already deployed everything. And then the remaining tasks are left that are data preparation for demonstration into Gazelle, uh, creating a demo using the demo creator for easy and interactive demo. And then there is the last task, that is the documentation and defining the maintenance task. So yeah, the impact of this project would be it will be helpful in demonstrating end-to-end social protections using a single unified environment. It bridges OpenG2P and Mifos ecosystems in a reproducible local setup, and it validates a full government-to-person payment lifecycle using the existing OpenG2P and Mifos. Next slide, please. So thank you to my mentors and Mifos community for their guidance and support throughout my journey. And if you are interested in this project, or if you just want to connect, you can ping me on LinkedIn, GitHub, or via my Slack. So yeah, that's it.
Thank you very much, Mohammad. That's great. And yeah, another great functionality to see. It's great that a lot of these DPGs we work really closely with. And in fact, Mifos was one of the founding people that started OpenG2P, are now coming together in these end-to-end flows. It's really showing the value of DPGs together and what they can offer for DPI. So it's great to get some of these key integrations in. Thank you for your work. Next, we're going to segue a little bit into Payment Hub. It's still quite relevant to Mifos Gazelle because Mifos Gazelle consumes Payment Hub as one of its flows. But I'm delighted we're going to hand over to Giulio to talk about what he's doing about Payment Hub, which will be a key part of our Payment Hub 2.0 release we're hoping to have later this year. Giulio, over to yourself.
Hi everyone, I'm Giulio. I'm a second year computer engineering student at the University of Bologna in Italy. What brought me to Mifos is the fact that it brings together my two passions, software and finance. I find it genuinely fascinating to understand what actually happens underneath a payment, and at the same time to be a part of the good that Mifos does. My project this summer is updating Payment Hub dependencies, bringing every Java component of Payment Hub onto a current and fully supported technology stack. This is exactly the kind of engineering I care about most, keeping production systems secure and maintainable over the long run. And in Mifos, that is really important because this code moves real money for real people. Carrying on with the slides, Payment Hub, it's the payment orchestration layer of the Mifos stack, with around 33 small Java components. These components were all end-of-life version, as you can see, Java 8 through 13, Spring Boot from 2.1 to 3.1, several stopped getting security patches years ago, which is serious for a system that moves money. A big part of the work is the move from Java's namespace to Jakarta. When Java went from Oracle to the Eclipse Foundation, Oracle handed over the code but kept the Java's name itself. So to keep evolving the APIs, Eclipse had to rename every package to Jakarta. From then on, Spring Boot 3 and Camel 4 only run on Jakarta. Also, doing this across 33 components by hand would be impossible to keep consistent. So the core of my approach is a shared BOM, one place that owns every version. That means a platform-wide upgrade or a security fix is a single change instead of 33. All right, for the next slide, where have I actually got to? First, 15 connectors are migrated and built green on Java 21 and Spring Boot 3.4. That's the code work done. But it compiles is not the same as it works. Six of them are actually running live on a real Kubernetes cluster on Mifos Gazelle. They start up clean, no old dependencies, all the camera roots come up healthy. And that distinction is real. One connector compiled perfectly, but crashed the second it started up because of an old library that didn't work with the newer web server under Spring Boot. You would have never catch that from a green build. I caught that only by actually running it. And the one thing I'm most happy about is that I ran a real end-to-end payment through the migrated connectors, going through the migrated channel, module loop, AMS Mifos connector, with the migrated importer recording it in the database, and it compiled. I could see in the operation consoles the money actually moved, and I repeated it several times. So for the next slide, what's next? So a few things. First, I want to test the bulk or batch payment flow end to end. So far, I've proven the person-to-person payment, and the batch flow goes through a different set of connectors. Second, broaden the coverage, so get the rest of the connectors booting cleanly on Gazelle, and use the integration tests for the ones that talk to external providers I don't have locally. And for third, this is where I got plenty of help by the community. The project direction is evolving in a good way. Alex, the chief architect, is building shared Gradle convention plan. He is building shared Gradle convention for all of Mifos, which will eventually replace the per repo build files and my BOM. So my plan is to adopt those. The one thing I'm waiting on is this. Right now, its conventions it only targets Spring Boot 4.0, and my migration is on the 3.x line. So my ask is really just for Alex, once he expands the convention to also support Spring Boot 3.x, I can integrate them into my connectors. Until then, I keep moving on my own setup so I'm not blocked. And but why does all of this matter? Two honest reasons. So the first one is security, because the payment engine is back on supported frameworks, so no more unpatched vulnerabilities sitting inside a system that moves money, and also maintainability, because a modern supported stack keeps payment up alive and easy to upgrade. So for the next slide, to wrap up, keeping a payment system modern without ever breaking it is a generally hard problem, and that's exactly why I wanted this project. Every change is small and important, but the result is a payment hub that's secure, maintainable, and ready for what comes next. Before I finish, a huge thank to my mentors, Tom and David, for their help and their patience, and to everyone in the Mifos community who took the time to help me. And if any of this sounds interesting to you, dependency management, keeping production systems secure, or the payment hub internals, please reach out. I'd genuinely love to talk. Thanks so much for listening.
Thank you, Giulio. As you say, it's such an important project, this one. Removing some very horrific dependencies so elevates our security and so what we need to do and continue doing and maintain into the future moving forward. So really key work for us. Thank you for all the effort you're putting in. It's great to see some of the fruits and real payments flowing across the new secure modules already. Staying on that theme of security and payment hub, next we're going to move on to Ruphine, who's been looking at security and payment hub from a slightly different perspective. Over to yourself, Ruphine.
Hello. Am I audible, please?
Yeah, we can hear you, thanks.
Okay, so I am Ruphine Kengne. I'm a back-end developer and an API analyst from Cameroon. I have a Master of Science in Electrical and Computer Engineering, measuring in software engineering and security. And I'm working on the project API Security Assessment and Penetration Testing for Mifos Payment Hub application under the mentorship of Kengne. I have been in the Mifos community since 2018, and I've participated for GSOC, for the Google Summer of Code for the first time under Mifos, under FINERAC, and I have been a mentor of Richie under the Mifos organization, and I contributed to pull requests to the Mifos source code and the FINERAC backend application. So I joined Mifos because of his mission to eradicate poverty and to help people gain access to financial services. Please, next slide. So the Payment Hub application is a payment orchestration engine responsible for coordinating and routing payment between core banking system and other external system. So the Payment Hub exposes multiple API for payment initiation, status query, and operational management. And this creates a large surface area for critical risks. So the main goal of this project is to identify, document, and provide mitigation to the security vulnerability found in the REST API of the Payment Hub application. And this testing is carried out in alignment to the OWASP, that's the Open Worldwide Application Security Project, API Security Top 10, and Real World Payment Threat Model. So this assessment on the Payment Hub will help the community, has a lot of benefit to the community, like it will improve the security and the reliability of the Payment Hub application, and it will also help institutions to deploy the Payment Hub with greater confidence. Please, the next slide. So the first step of this project was to create a threat model document. First of all, threat modeling is a structural approach to proactively identifying, assessing, and providing security mitigation for vulnerability and threat found in the system. And this process is important because it provides a better understanding of the architecture, because during the process you have a particular look into how the different components communicate together, and also the output of the threat modeling process serve as an input to other security processes like penetration testing, risk management, and code review. So in the threat modeling process, the first step is mapping the flow of data between the different components. So that's where the data flow diagram come into place. Here you see the main component of the payment hub, how information enter into the payment hub. Here you see the important assets of the system, that the component you care about, the trust boundary, where you want to secure, where your focus is to secure the system, and how the data flow from one end to the other, and the different way the component communicate together. And from this diagram, you see that the trust boundary payment hub is our main area of focus, and the payment hub communicate with other external components like the Mojalo, the Mifos X, and Apache Finirac, and also the customer or the payer that wants to use the application for transaction. And also there are other processes in the trend modeling. There are other steps in the trend modeling process where you identify trend using structural methodologies like the stride and the pasta method. And you also assess the risks and prioritize them, and also provide security recommendation for the different vulnerability and threat you have seen in the system. Next slide. From the trend modeling process I carried out, I discovered some threats in the system, and I provided some security control to mitigate them. One of them, like some of them, is like the unauthenticated payment initiation. Currently, any payer on the internet can send a request to the payment hub through the channel connector, because it doesn't have any credentials. So there's nothing on the system currently to validate who is making that transaction. And this kind of thing is not very good for a financial institution, because in a financial institution you want to keep track of you want to have audits and logs. We keep track of who carried what on the system. So a way to mitigate against that is to enable authentication on the channel connector. That's the entry point into the payment hub application, and that authentication will be to validate any API key and token for incoming requests. Also, another threat I discovered was that there's no rate limiting on any of the public API on the payment hub. That means that an attacker can send a high volume of requests at a time to the channel connector, and it can cause resource exhaustion, preventing payment to be processed. So to mitigate against that is to implement rate limiting on all the public API. Another threat I found was that credentials currently in the system are written in plain text, and anybody that has access to the system can get those credentials and carry out transactions on the system without the system admin on the payment control, on the payment hub control, to identify who made the transaction. So a security control for that is to replace all the hard-coded value and keep them in a secret management system. And I also identified top risks in the system, like no authentication, which we discussed, sensitive data exposure, and the denial of payment hub. So I've included the link to the threat modeling document that contain all this information on what was carried out in the first step of this project. Please, the next slide. So the next part of the project is to carry out an API penetration testing to identify vulnerability that align with the OWASP API security top 10. So these vulnerability discovered here are the vulnerability found on the payment hub, as well as the external component connected to the payment hub, because an attacker can take advantage of a third-party application to get into your system and steal information from and steal your data, your sensitive information, or to corrupt your system. So the first vulnerability discovered is a broken object property level authorization. That's excessive data exposure. So this vulnerability is when the system retain more information than what is needed. This vulnerability was discovered on the Finerac API, because the Finerac API is also connected to the payment hub. Yeah, when it retain more information, like when you want to get a client by the phone number, it retains all the list of the clients in the database. So anybody that runs that endpoint is able to see information which the person is not supposed to see, and that affect the confidentiality of the system. And when you see information that you are not supposed to see, you can use it to cause havoc to the system and expose people information which you are not allowed to. Another vulnerability that was found again on the Finerac API was the course misconfiguration. Course configuration happen when you define a particular domain that you want to allow to talk to your API. So when that configuration is misconfigured or is not configured at all, it means that all domain can connect to your API, and when they can connect to your API, it exposes your API to attacker. They can steal information there. They can steal information there and use it for other malicious reason, affecting the reputation of your institution. The next vulnerability, unrestricted access to business flow. This one was discovered on the payment hub itself. And this vulnerability deals with flaws that are identified in the business logic of your application, which an attacker can make use of, or which can affect the reputation of your organization. The first one was transferring money to a non-existent account. So I discovered that I tried transferring money to an account that doesn't exist in the system or in the whole deployment setup, and the transaction was successful. I did not receive an error of account doesn't exist. When I went ahead to investigate, I discovered that the system, instead of returning that error to the user, it takes the first available user in the database and make the transaction to that person. So if this vulnerability is allowed or if it's deployed, it can seriously affect the trust or the customer trust in your organization, because at the end the customer will see that his account was debited but the receiver did not receive the money, and the money went to somebody else. That can affect your organization in a great way. The other one was transferring of a negative amount. I believe that any financial institution, like the user facing site of the organization, of the application, should not allow the transfer of negative amount, because an attacker can take advantage of that and either reverse a transaction that has been made, or even create an arbitrary account that exists on the system. Next slide, please. So this is a screenshot I took on the payment hub when I carry out a negative transaction to actually see the return from the system. And I discovered that the payment hub application return information that the transaction was carried out and it was completed, and it even returned a transaction ID. But when I went ahead to check the account, if the account of the payer, if the account of the sender or receiver was debited or not, and I discovered that the account were not affected, but the payment hub noted that the transaction when was completed and it returned the transaction ID. This is a flaw in the system which has to be corrected. And if it doesn't, it can affect the reputation of the organization and even destroy the customer trust in the application. And since this is a financial system, it's really something that has to be high priority. So this API penetration testing is ongoing, and by the end of the process, a full report will be presented with all the vulnerability found, the picture representation of the evidences, and the recommendation to mitigate those vulnerability, like for the transfer of the negative amount, a check has to be like an input validation has to be met to make sure that no negative amount is sent to the system. And also an API security checklist will be done so that before the system will be released to production, the API will be well secured to prevent any of these vulnerability from happening in real life. Next slide. The project has been interesting so far, but at the beginning of the project, I faced some challenges because the resources on the payment hub online is not up to date, have not been updated, and Postman API collection for the project has not been updated, and it was kind of difficult to understand the system because a lot has changed from the documentation online and what is implemented. But I had a session with one of the mentor, Tom Daly, which was of great help, and he helped me to go through the system to understand it to this point. And I am grateful for that. Yeah, thank you. Next one. Next slide, sorry. Thank you very much for listening, and thank you to my mentor Kaylin and to the community for the help and support through this project so far. So if you are interested in API security, secure coding, and security in general, please reach out, and yeah, my contact for future connection. Thank you.
Thank you very much, Ruphine. That's very interesting, and it shows the dedication we've got to actually look at some of these issues we've got in our development code at the moment before we move to the next release version. So definitely things we need to sort out, get answers for, and things implementers need to consider in terms of what defaults they need enabled, etc. So thank you very much. Very interesting. Next time we move on to Silky. Silky's been looking at Mifos X. And looking at smart contracts and loan agreement summarizations, a bit of AI mixed in with it as well. Silky, over to yourself.
Hello, everyone. Am I audible?
Yeah, we can hear you.
I'm Silky Vyas, a computer science student, and I'm from India. And this summer, I've been contributing to Mifos through Google Summer of Code. My project is Mifos X Smart Contract and Loan Agreement Analyzer, where I'm building an AI-powered assistant that helps borrower understand complex loan agreements in plain language. Before GSOC, I'd contributed to several open source organizations, but what made Mifos different for me was the community. It wasn't just about writing code, it was about building software that can genuinely improve financial inclusion. My long-term goal is to build trustworthy AI systems that solve real-world problems, and this project has been an incredible opportunity to work towards that. Next slide. Let me start with the problem we are solving. Loan agreements are often filled with legal terminologies, and most borrowers simply don't understand that. Important informations like hidden fees, penalties, repayment conditions, and default clauses are buried inside dozens of pages. Even something as basic as checking whether an EMI has been calculated correctly usually requires a manual work. So, our goal was simple: transforming complex loan agreements into clean, verified, and actionable insights. The system extracts financial entities, validates every important number, detects risky clauses, generates a borrower protection score, and finally produced a plain language summary that anyone can understand. In short, instead of reading a lengthy legal document, users receive an explanation they can actually make decisions from. Next slide. So where I've got to. Over the first half of GSOC, I've been focused on building an entire production-ready foundation. The application now extracts over 20 financial entities with high accuracy. It includes 95 plus passing tests with over 85% of code coverage. I implemented a 5-layer of validation pipeline so that model doesn't simply generate answer, it verifies them. The application currently supports 4 different LLM providers through a unified provider abstraction layer, making it easy to switch model without changing application's logic. Alongside the AI pipeline, I also completed Docker deployment, CI/CD workflows, and security hardening Next slide. So, midterm progress. Looking at the roadmap, every planned milestone for phase 1 is now been completed. That includes backend architecture, React frontend, contract segmentation, structured extraction pipeline, validation engine, borrower summary generation, premium UI, fallback mechanism, testing, and deployment infrastructure. So, the midterm stage, phase 1, is functionally completed and provides a solid production ready base for future work. Next slide. Instead of explaining the application first, I'd like to quickly show you working it in real time. Can you just please play the video? This is the extraction fields, borrower protection score, the plain summary, match check, and WhatsApp message. Then there are the fields extracted, the entities extracted with the proof from the clause or line they are extracted from. Nextly, there is a risk score and defaulters. Next slide. Although the demo looks very simple from outside, but every section of this dashboard represents a different AI or validation pipeline working together. Let me briefly explain you what the modules does. Firstly, the screenshot first is of analysis dashboard. Everything begins with overall analysis dashboard. Instead of overwhelming users with pages of legal text, the application immediately summarizes the contract into key financial insights. It generates borrower protection scores, highlights primary concern, and even provides a practical negotiation tips. For example, suggesting a lower prepayment penalty or requesting additional borrower protection before signing. It's not just a summarizing, it's giving a actionable advice as well. The screenshot second and the screenshot fourth. These are the entity extractions. The system identifies more than 20 financial entities such as loan amount, interest rate, prepayment duration, processing fee, penalties, and repayment dates. Most importantly, every extracted value is linked back to its original sentence in the contract, allowing users to verify exactly where the information came from. The third screenshot, risk analysis. After extracting the information, the application evaluates borrower's risk. It identifies clauses that could negatively impact borrowers, such as high interest rates, severe payment penalties, asset seizure condition, or usually larger default triggers. This allows borrower to understand potential risk before signing the agreement. The fifth screenshot, one of the feature I found especially valuable was default triggers. Instead of hiding these clauses inside legal language, the application lists every event that could put borrower into default, helping users understand exactly what obligations they are agreeing to. The sixth screenshot of math validation. Rather than assuming the numbers in the agreement are correct, the application recalculates them, flags any inconsistencies, provides an additional layer of financial transparency. Together, these modules are unstructured transforms unstructured legal contract into something that is transparent, verifiable, and genuinely useful for borrowers. The goal wasn't just to build another chatbot. The goal was to build an AI system that borrowers could actually trust. Next slide. Challenges and how I overcome them. One of the biggest lessons I learned during this project was building reliable AI systems is much more than prompting an LLM. I discovered that financial application requires precision. A surprisingly difficult bug, which was funny to me as well, was the Python's floating point arithmetic, where small decimal errors caused perfectly invalid EMI calculations. Another lesson was that validation is often more important than extraction itself. Rather than trusting model output, I built multiple validation layers that verifies values before presenting them to user. Finally, I learned importance of designing production-ready software from asynchronous APIs to Docker to automate testing and CI/CD. Next slide. To conclude, phase one has successfully delivered a production-ready intelligent loan agreement analyzer that combines large language model with deterministic validation to improve transparency for borrowers. Looking ahead, I'll be focusing on deeper Apache FinReact integration, comparative loan analysis, multilingual support, document upload and capabilities, and Olama integration. For the community, I'd especially appreciate the access to more real-world anonymized contracts, integration guidelines, and feedback. Before I finish, I'll leave with one funny lesson that I learned this summer, that the hardest bug I solved wasn't of the code or AI, it was about Python's floating point arithmetic. That was funny to me as well because I almost spent like 4 hours debugging this bug. But the fix turned to be that we should not use decimal with money. And that's why all the accuracy was failing. So the lesson learned to me was that never use decimals in money. Finally, I'd like to sincerely thank all of my mentors and entire Mifos community for their guidance, support, and feedback throughout this journey. Thank you for always being the supporter to me. And thank you so much. And really, I'm very grateful for this opportunity.
Thank you, Silky. It's very impressive seeing what you've done in such a little time. And I think that call out you had to the community about getting real examples so you can actually, exercise this is a really important call out to the community. So we'll make sure we take that forward with our partners to get those sort of examples in for you. Moving on from that, we're going to stay on the theme of AI, and we're going to go across to Mohit next to look at what we can actually do for our own community, a bit more internal looking, using AI tools. Over to you, Mohit.
Okay. So, hello everyone. My name is Mohit, and my project is AI for developer productivity. So before going to my project, let's get to know who I am and what my project is. So I am from India, and I am currently pursuing information technology, and I'm currently in 4th year. So coming to why I joined Mifos or why I started contributing to Mifos. So actually, seniors from my college were already contributing to Mifos, so it was kind of easy for me to get in the community. Along with getting in the community, the mentors I talked with, they were pretty responsive. They were pretty patient with me. So I felt that the community was approachable, so I kept contributing to it. Okay, so coming to my long-term objective and personal goal, they are sort of same. I don't want to keep myself to software or programming only. I want to build or contribute to something that lasts and impact, and hopefully keep my name alive even after I am dead. So can we move to the next slide? So what is this project, AI for developer productivity? It seems pretty vague. When I read it for the first time, I also find it vague, but now after discussing so much with our mentors, I think I can explain it better. So as you know, there are a lot of tools that are using the capabilities of artificial intelligence, LLMs, to make life easier for developers and maintainers. And this is especially useful in a community like Mifos. So additionally, this project mainly uses AI to solve several challenges that developers face in contributing to open source, especially Mifos, what developers were facing. So initially, some challenges that were mentioned in the problem were there are large number of contributors contributing to the Mifos nowadays. So it is difficult for maintainers to keep reviewing it, keep setup, and look for bugs in the new contributed code, especially with the advent of AI assistants. The contributors are producing code at a higher rate, and also many a times contributors don't even know what they are contributing or what they are programming. Along with that, there are very some redundant tasks, or you can say some boring tasks that developers have to perform, like documentation that developers find it boring, or to maintain test cases, but they're pretty much important for new developers, and they're pretty much important for improving the quality of the software. So initially this was the three to four challenges that we identified and that we plan to solve in this internship. So can we go to the next slide? So this is the first project that we worked on. So this was, as you know, Mifos deals with the financial transactions, financial data. So keeping it secure, keeping code secure, and keeping data secure was pretty important. So we first decided to work on this tool. So, but this is security review for pull requests. So we decided to make an GitHub action that runs on every contribution, every PR, and then it checks for security vulnerabilities in the newly contributed code. So whenever a contributor raises some pull request, it performs analysis to find issues in the code. So what we did, it follows 3-layer architecture. As you can see, it checks for if you add some new dependency in the code, it checks for vulnerabilities in that dependency using OSB. Also, there are some custom requirements that each Mifos repo can require. Like for example, if we come to the backend of the Mifos, so we don't want someone console logging some private user info in the logs. So we can declare custom security rules. Third one is at last we send the code, we send the findings, we send the dependency vulnerabilities to LLM and get a structured review. So as you can see, I have added a option for config.yml. As you know, Mifos has lot of repositories, lot of different projects. So this action needs to be modular or customizable for every repo. So the files to be ignored, the important files, the custom security rules, all can be defined in the config file. Also, one issue I faced and the one feature requested by my mentor was that for the first time when someone opens a PR, it will get reviewed. What happens if it fixes the PR and commits again, or if it closes the PR or opens again? So we should also give feedback to the contributor that yes, you have fixed this issue, but you have introduced some new issues. So we also do this. So coming to technologies we used, we made this tool in TypeScript and it currently uses OpenAI, but we are planning to add support for local LLMs and also some more providers. So coming, can we go to next please, so we can show the architecture. So this is how it works. Currently, as you can see on my left side, let's assume that you have some issue on line 19. You put some hard-coded secret, or you wrote an SQL code that can suffer from SQL injection. So it will give this inline comments explaining the problem, how we can solve this solution. And one feature that I added was prompt that we can give to our assistant to solve this issue. Along with that, there can be several issues in the same PR. So it also posts a summary of that, as you can see on the top right part. And as I mentioned about config.yml, so different repositories can add the following config in this format to customize this tool. So I think this is one of the things that will continue to evolve. The config will allow different repositories to customize this tool according to themselves. And coming to next tool, coming to next slide, we can. Yes. So while designing this, I had some discussion with my mentors, and they said if we are analyzing the code changes and then looking for, you can say, vulnerabilities, we can also update our documentation, Mifos documentation, based on the code changes. So after, I think, 4th week, I started working on this. So David shared with me a drive with all the Mifos documentation. So this is currently the diagram. You can think of how Mifos documentation is scattered. So Mifos has several products like Payment Hub, Gazelle, Mifos X, Findirect, Mobile, and all. So mainly documentation is divided for three audience. One is for end user, one is for implementer, and one is for contributor or developer. And majorly documentation is scattered across I think I missed it, but the documentation is scattered across Gitbook, README, and Confluence, and also a SkyDoc. A SkyDoc is used in FinTech. So these are the four places where documentation is scattered across. So what we have built till now in this is that whenever a code is merged in the master branch, again we can decide which branch is master in this repo using config. So whenever the code is merged in that branch, we fetch all the code from that commit, decide which audience is affected by the code changes. Either it is a end user or it is a developer. Like if we made some changes in API, so it is intended for updating documentation for developer. Then based on things mentioned in config file, we decide documents to update and which platform the documents are currently on. It can be either Gitbook, it can be README, it can be Confluence, or multiple. So currently the action supports updating Gitbook, README, and Confluence. Gitbook and README were kind of same because we cannot directly update Gitbook. We can only fetch data, but we cannot directly update Gitbook. So I came up with a clever solution, I think. But there is an option for sync with GitHub in both Gitbook and README. So if you update GitHub of docs, then the documentation is also updated on Gitbook and README. So this follows that, and I use Atlassian API for updating on Confluence. Now I'm planning to add support for Sky docs, but for that I think I need to update comments in that. So I will work on that. Coming to that, another problem that my mentors mentioned was that the documentation is pretty scattered. So that the sheet that it was shared with me, it was full of missing pieces, and the documentation is pretty scattered. I had to look for 2-3 days to understand the structure of documentation. So another thing that my mentors come up to keep this documentation in one space. As I am already fetching the documentation using APIs, so we are planning to keep all this documentation for users, for implementers, developers, for all products on one interface that can be used as a single interface. Okay. So coming to how I progressed through 5 weeks, 6 weeks is not mentioned, but yes. So for the first 4 weeks, I finished my PR review, and then I started working on the documentation update. All these are Jira tickets mentioned here. Coming to future plan, as I mentioned, in the next till the next week, I will work on integrating a SkyDoc and adding sports and finalizing or making the pipeline more robust for documentation update. In the 8th week, I will work on making the single unified interface for all documentation. Also, there was some mention of using Jira as documentation update tool because Jira has all the worklogs based on the Jira tickets we make. So Jira is already extensively used in Mifos, so we can also use it to update our documentation automatically. This will be one of our future plans. Coming to the next slide, please. So AI for developer productivity is just not this one action. There are multiple things planned. As I told you initially, there was a plan for some automated testing. There was plan for MCP server that connects Jira and documentation and code. So we are planning to work on all of this. So if you are interested in building some tools that use AI, that are used by real developers, it will also make your life easy as a contributor. So if you are interested, you can go to this repo. All work is going on this repo. If you want to discuss something personally with me, you can contact me using these things. Apart from that, I want to thank my mentors Keshav and Aru. They helped me a lot, and even if I call them at night, they still pick my calls and answers. all my questions patiently. So a lot of thanks to them.
Thank you very much, Mohit. And I think it's great that we're going to get some really good tools here that really help our developers do something, but it also has that impact out to the end users as well, because we look at all those multi-different layers and in the documentation, etc. So I'm really excited about well, I'm really excited because I keep telling you I am, but I'm really excited about where this project goes and what it could actually mean for me, especially around documentation. So well done, and thank you very much for presenting that. We're now going to segue into something slightly different. So we're going to have Hossam next presenting, but this is actually something completely new for Mifos we're considering. So over to you, Hossam, to explain what it is.
Hello, everyone, and thank you for joining today. My name is Hossam, and I'm incredibly excited to walk you through the architectural foundation and the progress we have made and the road ahead for the Mifos Marketplace project. This project, our goal over the road hasn't just to been writing code, but to establish an enterprise-grade, secure foundation that will allow Mifos ecosystem to safely embrace the third-party extensibility. And let's dive deep into what we are making that, how we are going to make that happen. Next slide, please. So if you look at the screen, you will see the core vision of the Mifos Marketplace. Our objective is to design a secure and extensible two-sided marketplace platform, but extending a financial ecosystem is fundamentally different from extending a standard web app or CRM or CMS. You cannot simply install a plugin and then give it access to database. When you introduce a third-party code into a fintech environment, you are dealing with two massive challenges here. First, you must assume that the code is untrusted. Second, you can risk your core system uptime on external dependencies like online license server. If a bank loses internet connectivity, or if your license server goes down, we cannot allow their core financial engine to freeze, because if you call a plugin, then this plugin cannot call the home server it's depending on. So to solving this, our architecture is anchored on three main pillars. The first one is the system isolation. As you can see in the diagram, our marketplace services, the registry service, the metadata service, and JFrog Artifactory are strictly isolated from the tenant environment. The marketplace backend doesn't touch the core transaction processing engine. The second one is the zero trust security. We operate on strictly deny by default permission model. Plugins are sandboxed in scope tenant environment, requiring explicit granular consent from the tenant administrator before they can interact with any APIs or something. And our third, and perhaps most technically critical pillar, is the offline first license. We eliminate the single point of failure here of online server entirely. Our validation happens locally before the application even fully boots, using cryptographically signed X.509 certificates and local BKCS #12 trust key stores. This guarantees that the financial core remains protected, available, and completely independent of the marketplace uptime. Next. So how much of this have we actually built? We have hit some major milestones, starting with Epic One. We laid down foundational architecture. We didn't just build a simple Spring Boot app. We constructed a strict multi-module Gradle skeleton. This separates our core domain license hooks, and our tools into distinct isolated boundaries. And we established our database schema using Liquibase and API side and code first design. We actively moved away from clutter, verbose, Swagger annotation, and so on, relying instead on standard Jakarta validations and Spring Boot native problem details for clear error messages and compliant OpenAPI specifications. We tackled then the Epic 2A, which was building the cryptographic CLI license generator. To make offline licensing work, we built a standalone command line tool that bootstraps custom root CA. When a license is generated, this tool takes commercial metadata like product ID, customer ID, max instances, and encodes it directly into custom X509 extensions or IDs. The output is highly secure, password protective, BKCS #12 key stores file, ready for the offline distribution. That led directly into Epic2B, the offline validation engine, the mechanism that reads those key stores utilizing the bouncy castle cryptography API. We build a rigorous three-stage verification pipeline. The first one here is verifying the license that it was genuinely signed by root CA and hasn't been tampered or modified at all. It validates the system clock against the certificates, and then this is a temporal window check, and then the proof of possession. This is the most important one here because it ensures that the tenant doesn't just copy public certificates or shared certificates, but it actually possesses the private key via cryptographic challenge response, neutralizing the risk of like modifying the certificates or sharing them. Finally, alongside all of these features, we were working on a massive infrastructure win here, co-developing the Mifos convention plugin with Alex. This plugin standardizes the dependency management, code formatting, and security settings across Mifos projects, all Mifos projects. We are utilizing a Graal VM native CLI tool for project scaffolding. We are reducing onboarding friction for new contributors and creating a highly predictable code base, which is enhancing the working with AI assistants and so on. So we get rid of shitty code and building more ordered structures for the project. That plugin, what Giulio talked about in the introducing his project, which is Mifos convention plugin. Second, please. We have a powerful foundation now, but there is still work to do to complete the MVP. Here is our roadmap for the upcoming epics. Epic 3 is all about boot lifecycle integration. We have the validation engine now. We need to bend it to the Spring Boot process. We will hook the application runner to implement a fail fast mechanism if a plugin license is invalid or expired or tampered somehow. The bootstrap process will gracefully abort, outputting a clean descriptive troubleshooting message with, of course, the Spring problem details before the core application becomes compromised. Now, Epic 4, we will shift our focus for marketplace core module and the artifact pipeline. We will finalize the REST APIs for publisher, registration, and version lifecycle. Crucially, we will integrate our plugin upload endpoints directly with the JFrog Artifactory and configure automatic vulnerability scanning using JFrog X-Ray if it has malicious payloads, or so it will be blocked before they are even reach the catalog. Epic 5 now, we will implement tenant scoping. The tenant scoping is like, this involves creating the database relations for tracking tenant-specific installations, enforcing the permission scope, and mapping the gateway layer, building out a robust audit logging service to track all the events happen in the system. And in Epic 6, we will build end-to-end testing system for the entire life cycle and compile all developer guides, ASCII doctor documentation, and architectural decision to ensure the next one or anyone who will be interested in developing and working and contributing to this project can pick up exactly where we leave off. Second, please. Next. So I want to share a few core engineering insights here, technical takeaways from this phase of the project. First, diving into advanced Java cryptography was both challenging and incredibly rewarding. So we are generating X509 certificates and implementing proof of possession using bouncy castle. This gave us a profound understanding of how enterprise security actually functions under the hood. Second one is learning the true value of the modular design. We are enforcing strict architecture boundaries. Using Gradle modules, we guarantee that our core domain logic never bleeds into like our transport layer, persistent layer. It requires discipline upfront, but it pays off massively in testability and maintainability. It makes the code readable and easy to follow. And the third one is a modern API standard. We learned that less is more, moving away from heavy framework-specific annotations to pure Jakarta validation and Spring Boot's 3 native error handling made our APIs such cleaner and standard and easier to document. Lastly, we learned what zero trust implementation actually looks like in practice. The zero trust isn't just an architectural buzzword, it's a translation to highly practical backend code. It means that treating every plugin as a treat or something that is dangerous to our system until explicitly it's code. And realizing that simply checking if a certificate is valid or is insufficient somehow, we must like force the client to mathematically prove ownership via cryptographic challenges and so on. So we built a foundation here that is secure by design and modular and ready to scale. Next. I'd like to thank everyone in this wonderful community for the guidance and of course, my mentors for the feedback throughout this process. And I have contributed before to Mifos, and I love what they are working on. I want to grow big here, and I want to keep contributing and deliver a value, even if the marketplace project or even another one. I will keep contributing to Mifos, and I will be more than happy to open the floor for anyone who might ask a question. Thank you.
Thank you, Hossam. That's great. And I say I'm so excited about what this could actually be for Mifos moving forward. And it's a huge project that's so fundamental to all of our projects, Mifos X and others in the future. So really excited. And as you say, if anyone in the community wants to reach out to you and get involved, please do. There is more than enough work to do on this project, and it's really exciting for moving forwards. Heading back into Gazelle, we've looked at some of the new features that have been coming along in Mifos X and things like that. But now how do we keep getting all these new features that get delivered back into Mifos Gazelle and keep that up to date? And that's the focus that Kanishk is going to look at. So Kanishk, over to yourself.
Hello everyone, I am Kanishk Singh, sophomore at Medhavi Skills University, currently pursuing my BTech in Computer Science with specialization in AI/ML. I'm currently based in Bangalore, India. Why Mifos? I started my journey with Mifos few months back, and I wanted to contribute to open source project with some real world impact. And Mifos is exactly doing that by helping billions of people by powering financial services to underserved communities. My long-term career objective is to work on infrastructure and platform engineering for financial platforms and cloud native systems. Personal goal is to strengthen my open source skills and to learn from what I do. And fun fact, I am still figuring it out. Next slide, please. So the overview of the project is I have to bring the Mifos X, I have to update the Mifos X to the latest version of Gazelle. So what Gazelle ships today is FinRect 1.1.0 version plus Web App, which is right now it contains a dev tag, and the database which is used is MySQL and MariaDB. Currently, the versions which are used by Gazelle are three releases behind,
and also there are some missing modules. The goal is to modernize Gazelle Mifos X latest images and to update it to the latest version and also add some new modules such as the reporting plugin, credit bureau, and workflow engine. So what till now what I have found is to that right now FinRect is based on 1.11.0 version, and my target is to update it to 1.14.0, which I have completed in GAS 45. And web was based on a dev has release, but I have moved it to the current release, which is 1.12. But right now there is a blocker in web. The current image which is pushed to Docker only contains MD64, ARM64 support is not level, so we have to make multi-R image for web app. Database currently used by Gazelle is MySQL, and we have to move it to Postgres, which I will be covering in my Jira ticket Gas 305. And I will be also adding some new modules such as reporting plugin, credit bureau, and workflow engine. Next slide, please. So for reporting plugin, custom FinRect, I have done custom FinRect image with the reporting plugin baked in. The problem was that if you take the stock FinRect and ask it for report, it throws an error saying no reporting progress service registered for report type. In simple words, it means that the part of software that draws the reports is missing entirely. The only thing that is still work basic on-screen tables, no proper PDF or Excel financial statement at all. To fix this, I have built a custom version of the FinRect image. What I've done is I've added reporting engine itself with 71 files. Then I've added the actual report templates, the pre-designed balance sheet, income statement, and so on. And finally, I've set one configuration value that tells FinRect where to find those templates. The result is it works on first run and the system starts up in about a minute. It's a clean mechanism because it is built on the official FinRect image and it automatically picks up anything you place in specific plugins folder, and it is also repeatable. So, we can carry the same approach forward to future FinRect versions with minimal effort. Next slide, please. So this is my roadmap. I have completed GAS 43 and 44. Right now, I've completed GAS 45 from my side, but right now there is a blocker which I have already told that web needs to publish a multi-arch image. And currently, I'm working on the migration of Postgres. Right now, we are using MySQL for database, but we need to move to Postgres. And once I have done the migration of Postgres, then I can move to reporting image, credit bureau, workflow engine, which are the new modules which I will be adding in Mifos X. Then the deployment thing and release notes. Next slide, please. Huge thank you to my mentors, Tom and David, and the entire Mifos community for their guidance, support, and encouragement throughout this journey. If you have any question or if you want to connect with me, you can connect with me through these channels. Thank you.
Thank you very much, Kanishk. And as you say, this is a hard slog, but will get us somewhere so much better in terms of all the capabilities of Mifos X being there, and then something that's much more easy to update in the future. So it's really exciting to get it into there, and I know it's helping shape a bit of even our release process within Mifos X. Well, thank you for bearing with us. It's a really packed day today, so we have one final presentation, but it's definitely worth watching. So please stay with us. We're going to move across to Yash now, moving back into Payment Hub again. Just like a few years ago, we did started a migration journey to React from Angular in Mifos X. Well, we're going to do the same in Payment Hub. And I'm delighted Yash is working on a project. Over to you, Yash, to explain more about it.
Yeah, hello, am I audible?
Yep, can you?
Yeah, so hello everyone. My name is Yash, and I'm a final year student at IIIT Jabalpur, and my major is mechanical engineering. So my project is a payment hub operations, but in React. So why Mifos? Mifos was my first organization which actually matched my stack, unless like I've earlier used to open source in different stacks like Java, etc. And my personal goal is to ship multiplayer games or any interactive experiences that are targeted by real life audiences, etc. Next slide, please. Yeah. So the project is Payment Hub EE. Payment Hub EE is an enterprise-grade payment orchestration platform used by government and other financial institutes to manage large-size payment programs, etc. For example, taking an example of G2P payments, government needs to like send payments to thousands of beneficiaries. So the Payment Hub EE handles the validation, routing, and monitoring of all the transactions. My part is to rebuild the entire operational app, which was uh, coded in the legacy Angular library, and now I have to rebuild it in the entire latest React Vite framework. So the existing app is functional, but is heavy and hard to extend. Next slide, please. Yeah. So the existing app was functional, but is kind of complex and heavy to code and extend. So by adopting the latest React library, the code base will be faster to develop, easier to maintain, and simpler for the future contributors to code because every module I've made is self-contained. Next slide, please. Yeah. So it's the progress tracker. So initially I've created multiple, I guess 16 or 17 MVP slides in Figma, which was replicating the Angular one. And I've made some integrations and made more slides, which are now compatible with the React one. Then I've scaffolded the React project and built the core payment modules and the voucher modules. And currently I'm working on the account mapper module. Next slide, please. Yeah, thank you. This slide basically is showing the difference between the legacy Angular app and the one I've created, which is the React one. So in the left side, on the React one, I've tried adding more clear layouts and improved the visual hierarchy to the entire UI. Next one, please. Yeah. So the upcoming roadmap. So the immediate next step which I've planned is to complete the reporting dashboard and the modules, which include the account mapper, G2B configuration, RBSA management, and the entire user made settings. Once all the core UI is completed, I'll start integrating it with the Keycloak auth, wiring it with the login flow, token management, and the role-based viewing. And we'll migrate the entire data from mock data to the entire 10 stack query hooks as well. Next, please. Yeah. So that's my midterm update. Thank you, everyone. A quick shout out to my mentors, David and Victor, for the genuine guidance throughout. If you're interested in the React-based payment hub EE, please ping me up. These are my handles, and do reach me out. Thank you.
Thank you very much, Yash. Yeah, it's great to see how it's coming together and the shape of it. And I know I'm going to get to the demo when I catch up with you in the next couple of days as well. So it's really good to see what's coming on in this, and will give us something much more manageable moving forward. So I'm quite excited. This could be another key feature of our Payment Hub 2.0 release if we get it right. That concludes all the presentations this week. I mean, we've had some absolutely great presentations from all 25 of the interns across here. Before a bit of an announcement coming up, Ed, over to yourself. What's been your take on what we've seen this week?
Well, thanks, David. Yeah, no, I think just as each year we progress with our workings with our interns, it always astounds me, all the progress. So it's incredible how much all of our interns have already made thus far, only a short ways into the summer, across so many different aspects and so many solutions across the community. I think it's just going to be, yeah, overwhelming for all of our mentors and everybody to keep up with all the output that's coming in, to review it and make sure we can get everything the community can benefit from shipped from our interns. But it's really quite impressive to see the new innovation and all the areas where we're really pushing the boundaries of what we can do. And I really look forward to seeing the finished products of these efforts, as it's going to help, round out all aspects of our solutions from the back end, having better integrations, having it be more secure, polishing the UI of all of our different digital public goods, and then all the innovation we're seeing around our mobile apps and AI. So hats off to all of our interns for the great work so far. And a big thank you to David for all the efforts in organizing and coordinating everything so smoothly. And then a big thank you as well to the mentors who are behind the scenes, helping make sure our interns have the proper guidance.
Thank you, Ed. And as we said, please do engage with all the students over the coming days, and use the opportunity to help steer the projects as to get towards the end. And talking about what comes up next, hopefully. Thank you for joining us. See you in the summer.